So final question, I think, is 2018 question 3. And again, I'm going to do the whole lot of this. So firstly, we're given the equation for the neutralization reaction as HCl and NaOH. And you're asked, is the reaction exothermic or endothermic? And always really heat of neutralization is always exothermic. You are asked then to justify your answer. And the reason why you know that the reaction is exothermic is because the temperature rose. Okay, so the temperature goes up. Okay, so obviously if the temperature goes up, heat is given out to the surroundings. Okay, so that is what an exothermic reaction is. So B then, part I. Why should the mixture be stirred before taking the readings? And it's to make sure that your heat is distributed evenly. Okay, so even if you're making a cup of tea, you know, you'd use a spoon or a coffee to make sure the heat is distributed evenly. Okay. Part 2, suggest a reason why the temperature, having risen, then begins to fall, okay, gradually. And the reason why is, even though we are using a polystyrene cup, there is still going to be some heat loss to the surroundings, okay? And the longer that it is in the cup, obviously, the more heat loss there is going to be. So after a while, there's going to be heat lost. That will result in the temperature going down. Part 3, the thermometer used was accurate to 0.1 Kelvin. What temperature rise would have been recorded if the temperature was accurate to 1 Kelvin? Okay. So I have a 6.4 Kelvin rise, and that's using a 0.1 Kelvin thermometer. But that goes to 1 decimal place. But if I only had 1 Kelvin, it would go to the nearest whole number. So it'd be 6 Kelvin is the answer for that. Part C, why is it advantageous to use moderately concentrated solutions instead of dilute solutions? And again, anytime it allows a bigger or a larger temperature rise, the larger the temperature rise, the more accurate the temperature rise is going to be. Okay, so any one of those there would get you your marks. Okay, and again, that was very similar to the other question that came up in 2013, I think it was. Next then, part 2, draw or describe the hazard warning pictogram that should be on a container of NaOH. Okay, and NaOH is corrosive. So we have 2 test tubes. Okay, one is dropping onto hands. Okay, and then the other one is dropping into a test tube or a surface. Okay, so that is your symbol for corrosive. Next then, you're asked to calculate the number of moles of HCl neutralized in the cardboard cup. So firstly, I'm asked for HCl, and in the question I am told that I have 150 centimeters cubed of 1.0 molar. So I'm asked for my number of moles, and my formula is volume by molarity all over 1,000. So 150 by 1.0 divided by 1,000, and that will give me 0.15 moles. Okay, we could also do it 1.0 molarity. That is equal to 1 mole in 1,000 centimeters cubed. In this question, I don't have 1,000 centimeters cubed. I only have 150. So multiply by what I know, divide by the bit left over, 0.15 moles. Okay, so that's part I. Then you're asked the heat produced by the reaction mixture. Okay, that had a total mass of 310 grams, taking the heat capacity of the mixture to be that of water. Okay, 4.2. So my heat produced, and this is part 2. My formula is mc delta theta. Okay, M, I'm told, is 310 grams. C is 4.2, and I'm told in the question that it rises by 6.4. Now, just here, this is kilojoules per kilogram Kelvin. So because of this kg, I need to convert my grams into kilograms. So that's 0.310 kg. Okay. So I multiply those, 0.310 multiplied by 4.2 multiplied by 6.4, and that gives me a total answer of 0.310 multiplied by 4.2 multiplied by 6.4, and that gives me an answer of 8.3328 kilojoules. Now, when we're looking at heat of neutralization, remember it's always heat produced in kilojoules per mole. So that's my next step, okay? So in the question, we're asked the heat produced. So that's the answer to part 2. And then for part 3, we're asked to 1 decimal place the heat of reaction. So I know 8.3328 kilojoules is produced, but that is only produced in 0.15 moles. Okay, I have to find how much is in 1 mole. Okay, so what I do here, I multiply by what I know, I divide by the bit left over, so that's going to give me 8.3328 divided by 0.15, and that gives me 55.552 kilojoules per mole. Okay, just the final thing here, and there's just a couple of teaching points really. Firstly, heat of neutralization, always minus, so you have to put in the minus. Secondly, it is always in and around kind of minus 55 to 57. Okay, so if you're getting something totally off the wall, you know you've gone wrong somewhere. And remember, it is produced by 1 mole of H plus. So this case, it's H plus. So that's why it is your 55.52. Okay, and then part E. The results obtained in this experiment was about 3% below the expected value, which is roughly about 57, minus 57. State and explain a modification to the method described that would give a more accurate result. Okay. So there's loads of answers here. If you go onto the marking scheme, you'll find, probably about 10 or 15 of them. Firstly, we could use more insulation, or you can wrap in cotton wool, okay? And the reason why, or the explanation for that, would be that it will give a more accurate temperature rise, okay? The reason why, again, would reduce the heat loss to the surrounding. The second thing here is that in this question, and this is probably the biggest one, is that they told you use a plastic cup. And really, and when we did this, we used a polystyrene cup. And again, the reason why is because it is a better insulator. And because it's a better insulator, again, it will give a more accurate heat rise. Okay. You could use greater concentrations or volumes of the acids and bases, okay? Again, gives a more accurate temperature rise for those two. Next, you could also state that you would measure the volumes using a pipette or a burette, okay? Which would reduce your error in volume. So if you look onto the marking scheme, I'd say there's about 10 or so on there for you to look at.